We're going to do lesson 19. We're going to be substituting to evaluate addition and subtraction expressions. This can be found on page 215 in your workbook. And the first problem reads, my older sister is exactly 2 years older than I am. Sharing a birthday is both fun and annoying. Every year on our birthday, we have a party, which is fun, but she always brags that she's 2 years older than I am, which is annoying. Shown below is a table of our ages starting when I was born. So here they just give you a little situation to help you make more sense in the problem, because sometimes when you think of a situation of your life, it's much easier for your brain to process the information and to understand. Now notice this table. You might feel that you have seen this before. At the beginning of the school year, we did rates, if you remember, and then we did ratio tables, right? So this might be very familiar to you. Now it's going to help us to organize our information and for us to see the patterns much easier. Analyzing the table a little bit, we see that when I was 0 years old, my sister was 2 years old. When I was 1 year old, my sister was 3 years old. When I was 2 years old, my sister was 4 years old. When I was 3 years old, my sister was 5 years old. When I was 4 years old, my sister was 6. If you look at the data horizontally, you can see a pattern. And hopefully you were able to see that when every time that you're 0 years old, your sister is 2. So there's like an increase of 2 years if comparing my age and my sister's age. So looking at the table, what patterns do you see? Now, keep in mind, these are some of the patterns that I can point out, but you might have other patterns that are important and maybe that you might want to consider, because the patterns are going to help you to get your understanding going. So you should have noticed that every year my sister is 2 years older. Maybe some of you notice that there's like an increase of 1 if you're looking at the table going vertical. That's also a pattern. So looking at patterns in different ways, it's always going to be very helpful for you. Okay? Now let's look at the second question. On the day I turned 8 years old, how old was my sister? So now you're thinking, well, if I'm 8 here, how old is going to be my sister? Now keep in mind about the pattern that you saw before. You said every year my sister is 2 years older. Okay? So you can say, well, if I'm 8 and my sister's always 2 years older, then my sister has to be 10 years old. How do you know that? My sister is 2 years older. That's how you know that. And this is why you add the 2. Or you can just say the 8 plus 2, right? On the day I turned 16, how old was my sister? So now when I'm 16, how old is my sister? Once again, keep in mind the pattern that you saw. The pattern that you saw was that every year your sister was 2 years older than you, right? So if you are 16 and your sister is 2 years older, then your sister must be 18 years. How do you know that? Again, it's the same thing that we said before. Because your sister is 2 years older than you, or because you're just going to add the 16 plus the 2. Do we need to extend the table to calculate these answers? And it is possible, you know, some people might say, you know what, I want to go, complete the table and show them all the way to 16. It is possible, but it does take a lot of work. It might take you longer to get your answer, right? So knowing your math, or your algebra in this case, is really going to make your life much easier. So here for this question, this is going to depend on how you did it. Did you really complete a whole table? You say yes, and then you explain it. If you say no, then you explain why. So that part, you really have to answer it based on what you did. Okay, so now we're going to continue on page 216. And again, we have the same table that we used in the other problem before. We have my age in years, and we have my sister's age in years. And the question is, what if you don't know how old I am? Let's use a variable for my age. Do you guys remember when we did the lesson of variables the day before? Where we use variables when we didn't have a specific number. So here they're asking us to use y. Y equals my age in years. Can you develop an expression to describe how old my sister is? So they want us to look at the patterns that at the table, use y, like if we don't know how old I am, and then how are we going to apply that variable at the pattern so that we can determine my sister's age. Okay, so let's try this. We're going to use y for my age. And we got to keep in mind that my sister's age is 2 years older than I am. So to write my sister's age, I'm going to have to write my age, and then I'm going to have to add 2 years. And that is going to give me my sister's age. Another way that you can see it, I'm just going to make a rewrite how we got the answer on this side here so that you can see the pattern. And you're going to see how looking at patterns can really help you understand expressions. So when you're 1 year old, and then my sister 2 years older, she'll be 3. If I am 2 years old, and then my sister is 2 years older, then she'll be 4. I'm going to do one more. If I am 3 years old, and I'm adding the 2 years older, then my sister is going to be 5. Now, pay attention here. If you look at these numbers, those numbers keep changing, right? And if you look at the 2, those numbers don't change. The age stays the same. So anytime you see consistency, we call that a pattern. So it doesn't matter how old I am, my sister will always be 2 years older. In math, we keep the 2 because that one stays the same. It doesn't change, right? And then the number that keeps changing, we represent that with a variable. And if you think of the word variable, variable means changes. It doesn't stay in one value. So this is a good opportunity for you to see that every year that I get older, the number changes. And this is why if I don't know how old I am, I will represent it with a y. And it doesn't matter how old I am. My sister will always be 2 years older. And this is why we add the 2. And that will help me get my sister's age. So that's where the expression comes from. So this may be another way that can help you to understand it. So the first part says, can you develop an expression to describe how old my sister? We already did it. We already know that to get my sister's age, I can do the expression of y plus 2. There's no equal signs because expressions don't have equal signs, okay? Next one, please add that to the last row of the table, and we already did, so you don't have to worry about that. Very good, we're moving on. Okay, example number 2. Again, we're still using the same table. Now, keep in mind, they're using every single step because they want to teach you how to think, right? So let's see what the first question says. How old was I when my sister was 6 years old? So now they give you the sister's age, and they want to know how old I was. Now it's like thinking backwards, right? Did you notice that in the previous problems we were going like forward? I call it thinking forward. Then Eureka has a tendency, or reverse your thinking, like thinking backwards, okay? So because now they give you the sister's age, and you gotta determine how old were you. So just keep in mind how this problem is teaching you to think backwards or reverse thinking. So when your sister is 6 years old, you are how old? 4 years old. So let's write it down. 4 years old. How old was I when my sister was 15 years old? So if your sister was 15 years old, you know what? And we can even try to use the expression that we had on top. That was your sister's age, right? So if your sister was 15 years old, okay? If your sister was 15 years old, you can think, what number plus 2 got me 15? And if you're thinking 13, that is correct. That would have been 13 years old. Now think, how did I get the answer? Well, instead of adding, I kind of subtracted. And that's where we say reverse thinking. You're thinking backwards. How do you know that? Because we did 15 and then subtracted 2 years. And please pay attention, this kind of thinking, I really like how level 1 thinking is learning to do something. It's like thinking forward. But when you start increasing the level, it's like going backwards, reverse thinking, right? So that's how you start teaching your brain to think more algebraic. And we might want to write it in words too, because for some people, words might make more sense. So since my sister is 2 years older, I subtracted 2 years from 15.